We started dividing polynomials by polynomials today with group work on the whiteboard. Each of these polynomials to the left are required to be factored so that we can do the division. They make up these fractions that I have on your notes. So here are the polynomials to be factored, and we need them to be factored first. So I did write down factored equivalent forms, but I want to make sure that you're able to factor them there yourself so that you don't have a struggle when you're doing your practice. So go ahead and take some time to factor these. Hit pause and come back. Then we went through, let's go through steps for solving. You first need to identify the greatest common factors, if there are any, and then reverse distribute, goodness me, reverse distribute, which is another way to say you need to factor each polynomial. Sometimes you can also call that expanding. I have some examples that I'll do that will expand just so you're clear on what I mean by that. And then we determine excluded values, which are the numbers that would make the denominator 0. This, any number divided by 0 is considered undefined because we don't divide by 0. But it's all right to have a 0 in the numerator. That's okay. Then we'll reduce by eliminating matching factors. So we factor everything, determine what should be excluded from the denominator, and reduce the fraction. Once you have your binomials and trinomials factored, that makes this a really quick process. So what we'll do is we'll write the numerator factored, and that's 3 times x plus 4. And then the denominator factored is 7x times x plus 4. And you can see we have a common factor here. That's how we'll reduce the fraction. That's how we'll divide. But before we divide, before we reduce and eliminate a factor, we need to make sure that we don't allow x to be any value that would change the denominator to 0. So I have to exclude x when 7x is 0. To solve this, I would divide by 7. And x would be equal to 0. So I can't let x be 0, or there would be a 0 here. My denominator would be 0 times x plus 4. I also can't allow x plus 4 to be equal to 0. That means x cannot be negative 4. So the values that I'm excluding for x are 0 and negative 4. Either one of those would make the denominator 0. Now that I know what values to exclude, I can reduce my fraction by eliminating matching factors. So I can say that 3x plus 12 divided by 7x squared plus 28x is equivalent to 3 over 7x, as long as I do not allow x to be 0 or negative 4. Here's another example. If I divide 4x squared plus 4x by x squared, my numerator is 4x times x plus 1 when it's factored. And my denominator can be written as x times x. That's expanded. So here's my fraction. I see a common factor. I need to exclude x values that would make the denominator 0. So x cannot be 0. Then I can reduce my fraction. So I'll mark off an x in the numerator and an x in the denominator. And my simplified fraction can be written as 4 times x plus 1 divided by x. And I won't allow x to be 0. Next, I have 2x squared minus 12x minus 54. This, when it's factored, is when the numerator is factored, I have 2 times x minus 9 times x plus 3. And when the denominator is factored, I have 5 times x minus 9. I do have a common factor in the numerator and denominator, so I see how I'll reduce it. And in the meantime, I can't allow my denominator to be 0. So really, we're only concerned with x values. 5 is not equal to 0, so that won't be a problem. But x minus 9 could be equal to 0 if x is equal to 9. So I'll have to exclude 9 from the possible x values. I can reduce my fraction and divide by eliminating the common or the matching factors, and I can write my simplified fraction as 2 times x plus 3 divided by 5. And that's as long as I do not allow x to be 9. I have one final problem. This will work the same as the other ones that we've done. So we already factored 5x minus 25. We already factored 5x cubed minus 17x squared minus 40x. So go ahead and reduce these and determine the excluded values. And then, hit pause and work through this one. And then restart the video to make sure that we agree on what the answer should be, the simplified polynomial fraction after it's delivered, reduced. This last division problem, I have 3 factors in the denominator that could be equal to 0. So I have 3 excluded values. I just set each factor equal to 0 and solved for x. And then I reduced the fraction by eliminating x minus 5 as a factor in the numerator and also in the denominator. That gives me 5 divided by x times 5x plus 8, excluding negative 8 over 5 and 0 and 5. So I have all of these problems done. These are with binomials and trinomials. I didn't talk about the monomials yet, so let's look at these. I have 3 examples. We can expand the numerator and the denominator. That's one option. My numerator can be written, this is even, so I can divide by 2. And that would be 20, which is also even. I can divide that by 2. And that would give me 10, which I can divide by 2. And I get 5. 40 is 2 times 2 times 2 times 5. And then it's times x times x times x. That's x to the third. The denominator is 35x. So that's 5 times 7 times x. The denominator cannot be 0. So x cannot be 0. I won't concern myself with whether or not 5 is equal to 0 or 7 is equal to 0 because they're not. So that's not an issue. Then I can reduce by eliminating common factors. And what's left then is I can multiply back together. 2 times 2 times 2 is 8. And x times x is x squared. This is divided by 7. So I can reduce 40x to the third by 35x to 8x squared divided by 7. And this is as long as I exclude a 0 value for x. I could also think of this as looking for a greatest common factor for the numerator and the denominator. When I compare 36x and 24x squared, the greatest common factor is 12x. So if I separate 12x out from 36x, it's 12x times 3. And if I factor 24x squared, I can write that as 12x times 2x. I can't allow x to be 0. If 12x was equal to 0, then I could solve for x and x would be 0. Also, if 2x is equal to 0, that would happen when x was 0. So x can't be 0. That's my excluded value. Then I can reduce, divide, and write an equivalent fraction, 3 over 2x, and that is as long as x is not 0. When you don't have a variable in the denominator, you don't have any excluded values. And I can reduce this. When I write it as factored, considering the greatest common factor, then I could write this 15x over 3 as 3 times 5x over 3. And common factor is 3. So that leaves me 5x. No excluded values.